Hi, my name is Yui Gabriel, and today I'll be discussing two areas on the Unit 1 lecture exam that I seem to have some trouble on. So the first area I'll be discussing is about metabolic diversity among organisms, just trying to decipher what is a phototroph and a chemotroph, then specifically what is an autotroph and heterotroph. Second, I just didn't seem to pay as much attention to some of the major people that made contributions to microbiology, one of who was Louis Pasteur, and I will be specifically talking about how we disprove spontaneous generation and just talking about some of the experiments that he did to do so. So first, going back to metabolic diversity among organisms, we're going to first decipher what is a phototroph and chemotroph, and by looking at this flowchart, you just first start with all your organisms, and next you're going to look at what is the energy source for these organisms. So if a organism's energy source is sunlight, it is automatically a phototroph. If its energy source is not sunlight, it is a chemotroph. And the energy source for a chemotroph can be an inorganic chemical or organic chemical. So going back to phototrophs, we're going to break it down even further to see what is an autotroph and heterotroph. And you do this by looking at what the carbon source is. So if the carbon source is CO2, it is an autotroph, so making it a photoautotroph. If the carbon source is food or some type of organic compound, it is a heterotroph, so photoheterotroph. And some examples of a photoautotroph include an oxygenic type, which is cyanobacteria in plants, and if it's anoxygenic, it is green and purple bacteria. And if we're looking at heterotrophs or photoheterotroph, some examples include green bacteria and purple non-sulfur bacteria. Next, we're going to see what is a chemoautotroph. Again, we're going to look at the carbon source. If the carbon source is CO2, just like a phototroph, it is an autotroph, so a chemoautotroph. And if its carbon source is food or some type of organic compound, it is a chemoheterotroph. So some examples of a chemoautotroph include iron oxidizing bacteria, and for a chemoheterotroph, some examples include animals, protozoa, and fungi. And that's just a quick way of deciphering what is a chemoheterotroph, chemoautotroph, photoheterotroph, photoautotroph. Next, looking at Louis Pasteur's contribution. So Louis Pasteur demonstrated how microorganisms are present in the air, and this is what disproves spontaneous generation. So initially, his first experiment, he had two different nutrient broths in flask. One he heated and then didn't seal, which showed growth, and then he heated and sealed a different one, and that showed no growth. So this was just the start of his way to show biogenesis. So this experiment in particular, he used a special flask to be able to show biogenesis. First, he had just these straight-necked flasks, which allowed air to come in, and showing this, the air just came straight into the broth, and microorganisms grew in the broth. And then next he made this kind of S-shaped flask, and what that allowed was air for it to still travel through the flasks, but these S areas were able to capture the microorganisms. So any of the microbes that were present in the air was caught here and wasn't allowed to go into the broth. So while air was still able to go in, the broth remains free from the organisms because it was trapped. So this just showed how microorganisms do originate in the air or in fluids and not just spontaneously, and that it takes something living to form the growth. So with Louis Pasteur, we still utilize a lot of what he did to disprove spontaneous generation. Something common that we utilize today is pasteurization. So we are able to kill harmful bacteria and organisms without altering the taste of it by using high heat. So again, that's just one small example of Louis Pasteur's major contribution to microbiology, leading into the golden age of microbiology.